doing so. It's in these populations that Calhoun first observed what he described as a behavioral sink. I'll read his description verbatim. The animals would crowd together in greatest number in one of the 4 interconnecting pens in which the colony was maintained. As many as 60 of the 80 rats in each experimental population would assemble in one pen during periods of feeding. Individual rats would rarely eat except in the company of other rats. As a result, extreme population densities developed in the pen adopted for eating, leaving the others with sparse populations. Eating and other biological activities were thereby transformed into social activities, in which the principal satisfaction was the interaction with other rats. In the case of eating, this transformation of behavior did not keep the animals from securing adequate nutrition, but the same pathological togetherness tended to disrupt the ordered sequences of activity involved in other vital modes of behavior, such as the courting of sex partners, the building of nests, and the nursing and care of the young. In the experiments in which the behavioral sink developed, infant mortality ran as high as 96% among the most disoriented groups in the population. Even in the absence of the behavioral sink in the second series of 3 experiments, infant mortality reached 80% among the corresponding. The females had failed to find a role similarly withdrew, but rather to higher-level nest boxes that were unused by the active females. Naturally, with more males competing, the load on the dominant males increased as they were forced to constantly contend with fresh and desperate younger males. This lessened the ability of the dominant male to defend his territory, which caused a shrinkage of his domain. This also left many nursing females unprotected and left them exposed to invasions of their nest sites. This caused many females to become far more aggressive than usual, taking on the defending role usually reserved for the dominant males. Unfortunately, this aggression was generalized onto their young as well, with the females attacking, wounding, and even evicting young before they were fully weaned. Similar to the first paper, the conception rate decreased, and the absorption rate of fetuses increased as the maternal instinct became more and more disrupted, resulting in the notable decrease in the overall growth of the population that we notice in Phase C. Calhoun notes that for all practical purposes, there had been a death of societal organization by the end of Phase C. Phase D, or rather Phase Death, marks the demise of the mouse population, with the increase in population suddenly halting on day 520. Then deaths very slightly beating out births till day 600. And then the incidence of successful births declining quite rapidly until the last conception on day 920. This happened due to fewer and fewer successful weans and conceptions as more and more well-adjusted females aged past menopause. The root cause of this population death is explained by Calhoun using observations of the mice's behavior over Phase C and D. By mid-Phase C, almost all young had been prematurely rejected by their mothers and had thus been unable to create adequate social bonds. These mice would then emerge into an oversized population